Okay, so I'm going to, before this proof, let me just do another definition. You probably know it from primary school, an isosceles triangle. By the way, I don't care for spelling, so I have no idea if that's even close to correct. An isosceles triangle has two equal sides. And now the theorem associated with this is that the base angles of an isosceles triangle is equal. I suppose are equal to each other. Okay, now what do I mean by the base triangle? The base angles is an isosceles triangle. If I put it on the side that is not equal to the other sides, in this case it almost looks equal, but let's assume it's not. So let's assume these are the two equal sides, so that it kind of makes the legs of a mesh. Okay. Then the base angles are these two angles made with the floor. So if you stand with your legs apart, okay, then the angle that your two legs make with the earth are the same size. Okay. So let's look at the proof, and here in this proof will use congruent triangles to prove this. Okay, so here we have our isosceles triangle. A, B, C, and tell me what is mine to prove. The theorem says base angles of an isosceles triangle are equal to each other. So I've got an isosceles triangle. What must I prove?
To prove ABC equals ACB.
Good, I'm just going to do it like this. Angle B, let's do it the way you suggest. Okay, ABC is equal to ACB. Cool. For this one, we'll need another construction. And the construction that I'm going to do is I'm going to construct AN perpendicular to BC. What does perpendicular mean again? No, that's the conclusion. Perpendicular angles are adjacent angles that's equal to each other. Now the conclusion is that they're 90 degrees. Understand? That is the conclusion. They are 90 degrees because they're equal to each other and add up to 180. Okay, so perpendicular there. So we'll show that like that. And now I want to show that this angle here is equal to that angle there. So how I'll do that is I will show that triangle ABN is congruent to triangle ACN. So So I'm going to show that this triangle is exactly the same as that triangle. And if they are the same, it means that the corresponding angles, in other words, A must be equal to A, B must be equal to C, and M must be equal to M. Does that make sense? So if I can show that these two triangles are congruent, okay, there's three ways in which to do it. I either need to show that they have three sides that correspond, or that they have a side, an inclusive angle, and another side, or two angles and a side, or a right angle, a hypotenuse, and a side. Which one do you guys think can we show to be equal? Can we use to show congruence? The last one, okay. We can only use, just because there's a 90 degrees doesn't mean it's the last one, by the way. We need a 90 degrees and an hypotenuse. So you are correct, it is that one. Why? Because we have the perpendicular 90 degrees, and we have that the hypotenuse of the two are equal. That's given, because we have an isosceles triangle, that's given. Okay, so it is this one. So now we need a third side, or another side. Which side would they also have that's equal? Let's side AM. You see they share a side. It's like if you have a brother or sister and you share a room, not a room, but a wall. You've got two rooms next to each other, then you share a wall. Okay, it's the same wall. Just like these two share a side, it's the same side. It has to be equal. Okay, so we'll say in triangle ABM, in triangle ABM and triangle ACM, we have that angle AMB is equal to angle AMC. Okay, why are they equal? Why are these two equal? Why is AMB equal to AMC? Perpendicular, that's the definition of perpendicular. It's adjacent angles that are equal. Okay, so because AM is perpendicular to BC, why is AM perpendicular to BC? No, they're perpendicular by construction. We drew it like that. We constructed it like that. Okay, so by construction. Okay, so this is probably unnecessary, this by construction in this question. Okay, we often have to write it when we're using a construction. Like here we are using the fact that we've constructed ANB to be perpendicular. So that's why I'm using it. That it's true because we constructed it like that. Okay, and they're equal to 90 degrees. Okay, and that just follows from the fact that they are perpendicular. That fact you can just use. Okay, so both of them are 90 degrees. So we have the right. So we've shown this one. Now we have to show that the hypotenuse is equal. So then we can say, okay, AB is equal to AC. That's the hypotenuse of the two triangles. Why are those two side lengths equal to each other? Isosceles. It's given. It's given. Triangle ABC is isosceles. Okay, so we've shown that the hypotenuse are the same. Plural of hypotenuse. Hypotenuses. Hypotenuse. I don't know. Yes.
Can you also use the side angle side one?
Okay, so you want to use side, angle, side. So you need two sides and an inclusive angle. Which sides do you have? You've got AB
And AC.
and AC. They're equal. Which other side? You also have that. You also have that AM is equal to AM. That they have at the same side. So if you want to use this one, you need to have an inclusive angle, which is the angle that is made by the two sides you have. So you need to know that these two angles are equal, and you don't. Does that make sense? Oh. So you can't use this one not without some effort. I don't think you'll be able to use that one easily. Okay, so this one we need a third side, or thirdly we need a side. So we have 1, 2, and 3. Thirdly, we have that angle side AM is equal to side AM. So AM is equal to AM, common side. Okay. And therefore, we can now say that means the triangle ABM is congruent to triangle ACM. And the reason next to it you put is that we used the right angle, hypotenuse, side. If we used something else, we would use that shorthand. Okay, that's not what we wanted to prove though. We wanted to prove that angle ABC is equal to angle ACB. But that comes directly from this. We said that when these things are congruent, it means everything is the same. AB is equal to AC, AM is equal to AM, BM is equal to CM, A is equal to A, B is equal to C, M is equal to M. So it now follows that angle ABC is this angle ABM, the same angle. So ABM is equal to ACM, but ACM is the same as ACB. So, and why is this now true? From congruence. It comes from the fact that those two triangles are congruent. Cool. You see how we use congruence to show that certain sides are equal, certain angles are equal?